This is help for the prior knowledge section and the Gizmo warm-up section. So first, these two sections are really just to get some of your ideas out on paper, and also the Gizmo warm-up, that is to help you understand how this simulation works. So as always, read all of these directions. I'm going to quickly go through a couple important parts, but make sure that you're reading all of the directions. Watching this video is not completing everything. This is just extra help. So it says, the orbit of Halley's Comet, which is shown at the right, that's over here. The orbit of Halley's Comet is this right here. I'm tracing that with my red pencil or pen. It says that it has an oval shape. Obviously it does. It's asking you, in which part of its orbit do you think Halley's Comet travels the fastest? Is it on this side, here? Is it here or here? It wants you to mark these points on the diagram. So literally, you're going to mark the points on the diagram right over here. So tell me, do you think it's fastest here? Do you think it's here or here? What do you think? I'm not giving you the answer. I'm just showing you how to answer it. Then number 2 says, how might a collision between Neptune and Halley's Comet affect its orbit? So Neptune orbits around the sun on that type of orbital pattern. This is the sun, this yellow dot here. Let's say Neptune happens to be flying past Halley's Comet as Halley's Comet is going this direction, so they hit. This question, number 2, is just asking, how might a collision between Neptune and Halley's Comet affect Neptune's orbit? What do you think will happen to this orbit if Neptune smashes into Halley's Comet? Write your answer in that box on your worksheet. You might want to pause the video and then play it after you're done writing down your information. So now I'm going to talk about the Gizmo warm-up. It says the path of each planet around the sun is determined by 2 factors: its current velocity, which is just speed and direction, and the force of gravity on the planet. Now this Gizmo is going to allow you to manipulate both of those factors. We can change the amount of gravity on the planet and also the velocity. Essentially at its core, that's all that this simulation is going to let you do. And then once we change the velocity or the distance or the gravity, we're going to see how that affects the orbit. So it says on the controls pane of the Gizmo, turn on show trails and check that show vectors is on. So here, if we put show grid on, this can help you map it out so you can actually mathematically understand the orbit. We're not going to do that yet. You can show the focal points. We did this in class, remember? If we drag it further away, the focal points change, right? Closer, the focal points get closer. We're not going to mess with that yet. But here it wants us to click on show trails. So show trails. If I go back to the directions, it just says, on the control pane, turn on show trails and check that show vectors is on. Remember that vectors are just lines that show the speed and direction. This green vector is the gravity vector. It's always going to be pointing towards the center of the sun, right? Because that's the direction that gravity's going. Notice the further away we get, the less gravity. Remember Newton's law. The closer we get, the more gravity, right? So the longer these arrows are, is the more that force is, or the faster that force is. So the closer, the more gravity. You see the green arrow. But you can also drag and change the lateral velocity vector here. So you can make it go faster or slower. I'm going to refresh this because I just messed with everything. All right, so the directions, they just tell you to push play, right? Make sure that show trails is on. Make sure that show vectors is on. We're just going to hit play down here on the left. Now show trails shows you the path that the planet is following. Notice how the gravity vector, the force of gravity changes as the planet moves closer and further away. And notice how the velocity, the sideways speed and direction changes as the planet gets closer and further away. After you do that a few times, answer these follow-up questions.